Saturn, the magnificent ringed planet of our solar system, maintains a complex and ever-changing distance relationship with Earth as both planets travel along their respective orbital paths. This distance is not static, but varies considerably throughout their orbital cycles, ranging from just over 1.2 billion kilometers at their closest approach to nearly 1.7 billion kilometers when positioned at opposite sides of the Sun. The dynamic nature of this celestial relationship creates fascinating implications for astronomical observations, space mission planning, and our understanding of the architecture of the solar system. Saturn's distance from Earth represents one of the fundamental measurements that helps astronomers comprehend the scale and structure of our cosmic neighborhood. The distance between Saturn and Earth is in constant flux, as both planets travel through their respective orbital paths around the Sun. When the two planets reach their closest positioning, known astronomically as opposition, when Earth lies between Saturn and the Sun, they are approximately 1.2 billion kilometers, 746 million miles apart. This represents about 8 times the distance between Earth and the Sun, demonstrating the vast expanse of space that separates our world from the ringed giant. The minimum distance between Saturn and Earth has been more precisely calculated at 205.5 million kilometers according to astronomical measurements. This closest approach occurs when Saturn and Earth are aligned on the same side of the Sun, providing optimal viewing conditions for Earth-based observers. Conversely, when Saturn and Earth lie on opposite sides of the Sun, a configuration known as conjunction, the distance expands dramatically to approximately 1.7 billion kilometers, just over a billion miles. At this maximum separation, the distance stretches to about 11 times the Earth-Sun distance. More precise measurements place the maximum Saturn-Earth distance at 1,658.6 million kilometers. This substantial variation in distance, with a difference of approximately 450 million kilometers between minimum and maximum separation, results from the combined effects of both planets' elliptical orbits around the Sun and their positions relative to each other throughout their orbital cycles. The average distance between Saturn and Earth is difficult to pinpoint precisely because of this constant variation, but some sources indicate a figure of approximately 1.3 billion kilometers, 793 million miles. This constant shifting of relative positions means that Saturn's appearance from Earth also changes over time, not only in brightness but also in apparent size. The dynamic distance between the two planets creates a celestial dance that repeats with each synodic period, which is the time between successive oppositions of Saturn as viewed from Earth. Saturn's orbit around the Sun plays a fundamental role in determining its distance from Earth. The sixth planet orbits at an average distance of 1.43 billion kilometers, 886 million miles, from the Sun, placing it 9.5 times farther from our star than Earth. This substantial solar distance means Saturn takes approximately 29.4 Earth years, or 10,756 Earth days, to complete a single orbit around the Sun. The elliptical nature of Saturn's orbit means its distance from the Sun is not constant, but varies between perihelion, closest approach to the Sun, of approximately 1.36 billion kilometers, and aphelion, farthest point, of about 1.51 billion kilometers. Saturn's orbital path is inclined at 2.486 degrees relative to Earth's orbital plane, adding another dimension to the distance relationship between the two planets. This inclination, though relatively small compared to some other planets, contributes to the complex three-dimensional relationship between Earth and Saturn in space. Saturn's orbital eccentricity of 0.052 is about 3 times greater than Earth's eccentricity of 0.0167, meaning Saturn's orbit deviates more significantly from a perfect circle than Earth's path does. This difference in orbital eccentricity is another factor influencing the varying distance between the two planets. Earth completes its solar orbit much more quickly than Saturn, circling the Sun in approximately 365.25 days. This means Earth laps Saturn in its orbit regularly, creating a cycle where the two planets reach their closest approach approximately every 378.09 days. This period, known as the synodic period, represents the time between successive oppositions of Saturn as viewed from Earth. During each Earth year, our planet's faster orbital motion causes Saturn to appear to move backward in the night sky, retrograde motion, as Earth passes between Saturn and the Sun, a phenomenon that fascinated early astronomers and contributed to the development of our understanding of the solar system. Saturn's varying distance from Earth has significant implications for how we observe and study the ringed planet. When at opposition, Saturn not only appears at its brightest in Earth's night sky, but also displays its maximum apparent diameter of approximately 19.9 arcseconds as seen from Earth. Conversely, at conjunction, when the planet is at its most distant point, its apparent diameter shrinks to about 14.5 arcseconds. This variation in apparent size affects the level of detail visible through telescopes and influences optimal timing for both amateur astronomical observations and professional research campaigns. Despite the vast distance separating Earth from Saturn, the ringed planet appears nearly fully illuminated when viewed from Earth. This is because Saturn's phase angle, the angle it makes with the Sun and Earth, never exceeds approximately 6 degrees. This geometric arrangement ensures that Earth-based observers always see Saturn with nearly its entire sunlit hemisphere visible, unlike closer planets such as Mercury and Venus that display distinct phases similar to our Moon. When at opposition, Saturn achieves an apparent visual magnitude of approximately 0.7, making it easily visible to the naked eye as one of the brightest objects in the night sky, despite its enormous distance. The distance between Earth and Saturn also determines the travel time for both electromagnetic signals and potential spacecraft missions. Light and radio waves, traveling at approximately 300,000 kilometers per second, take between 68 and 93 minutes to traverse the distance between the two planets, depending on their relative positions. This communication delay poses challenges for real-time control of robotic explorers at Saturn, requiring sophisticated autonomous systems for spacecraft operations. For physical travel, spacecraft such as NASA's Cassini mission required several years and complex gravity-assist maneuvers to reach the Saturnian system, demonstrating the practical implications of the vast Earth-Saturn distance for space exploration endeavors. To better understand Saturn's distance from Earth, it helps to place it within the broader context of our solar system. Saturn occupies an intermediate position among the outer planets, being farther from Earth than Jupiter, but considerably closer than Uranus, Neptune, and the dwarf planet Pluto. When at their closest approaches to Earth, Jupiter lies at approximately 592 million kilometers, while Saturn is more than twice as distant at 1.2 billion kilometers. This positioning makes Saturn the second closest gas giant to Earth, though still at a distance that dwarfs the separation between Earth and the inner planets. Saturn's substantial distance from Earth reflects its place as the sixth planet from the Sun, residing in the outer solar system beyond the asteroid belt. The planet is almost twice as far from the Sun as Jupiter, the fifth planet. This placement in the colder regions of the solar system, where solar radiation is significantly diminished, has profound effects on Saturn's physical characteristics. At Saturn's distance from the Sun, solar irradiance is only about 1.1% of what Earth receives, resulting in extremely cold temperatures with a blackbody temperature of approximately 81 Kelvin compared to Earth's 254 Kelvin. The scale of Saturn's distance becomes apparent when considering travel times for spacecraft missions. The Cassini-Huygens mission, launched in October 1997, took nearly 7 years to reach Saturn, arriving in July 2004. Even utilizing gravity assists from Venus, Earth, and Jupiter to accelerate the spacecraft, the journey required significant time due to the immense distance involved. Historical missions like Pioneer 11 and Voyagers 1 and 2 similarly required years of flight time to reach Saturn, underscoring the vast gulfs of space that separate Earth from the ringed world and highlighting the technical challenges involved in exploring such distant regions of our solar system. Saturn's distance from Earth represents a dynamic and ever-changing measurement that reflects the complex orbital dance of planets within our solar system. At its closest, Saturn lies approximately 1.2 billion kilometers from Earth, while at its most distant, this separation expands to nearly 1.7 billion kilometers. This variation, coupled with Saturn's substantial distance even at its closest approach, creates both observational challenges and opportunities for astronomers studying the ringed planet. The vast distance between Earth and Saturn serves as a humbling reminder of the immense scale of our solar system and the technological achievements required to bridge these cosmic gaps through both observational techniques and physical exploration. Understanding Saturn's distance from Earth provides crucial context for comprehending the architecture of our solar system and Saturn's place within it. As both planets continue their orbital journeys, the distance between them follows predictable patterns that have been precisely measured by astronomers. These measurements not only help us appreciate the vast scale of our cosmic neighborhood, but also provide essential information for planning observations and spacecraft missions. Despite the enormous distance separating Earth from Saturn, our ability to study and appreciate the beauty of the ringed planet stands as a testament to human ingenuity and our enduring curiosity about the worlds that share our solar system.